High-frequency trading firms have spent the last decade laying millions of miles of straight-line fiber optic cable and shaving nanoseconds off hardware processing times. But that hardware optimization curve has hit a physical wall. We cannot build faster networks. The actual bottleneck in quantitative trading is no longer raw speed. The problem is absolute synchronization across vastly different, asymmetric network domains. Currently, financial infrastructure relies on protocols like Network Time Protocol, or NTP, and Precision Time Protocol, PTP. Both of these systems suffer from inherent microsecond clock drift. They are always slightly out of sync. This diagram illustrates what happens during execution. When two packets arrive at an exchange almost simultaneously, microsecond drift creates jitter. The servers experience probabilistic uncertainty, meaning they physically cannot agree on the exact chronological sequence of the incoming orders. Multiply that tiny fractional inaccuracy across millions of automated trades executing globally, and it translates into massive systemic financial slippage. Gaining an edge today means abandoning the race to lay faster cable. It requires a complete revision of how machines measure the baseline of time itself. A live machine-verifiable specification called FTU Spec version 1.7.1 provides the exact mechanism to solve this. It introduces the fatty tempo unit, or FTU, which discards standard atomic clock structures entirely. Instead of arbitrary measurements, the FTU anchors digital tempo directly to a universal physical constant, Planck-time, precisely 5.391247 times 10 to the negative 44th seconds. This is a strict measurement and interoperability convention built for immediate integration into digital architecture. A standard second is a human construct, constantly subjected to relativistic drift and leap-second adjustments. Planck time is the absolute minimum tick of reality itself. Establishing a Planck-anchored baseline ensures that every internal calculation is referenced against the universal minimum increment of time. This creates a structural consistency in the trading firm's data that legacy protocols cannot match. This framework is built upon the axiom of frequency. As this source documentation shows, the axiom states that all phenomena exist as a mapping from, or function of, frequency. Digital computation is simply a sequence of modulations. Therefore, time synchronization across a network is, at its core, an exercise in strict frequency alignment. This chart demonstrates how this principle governs all technological and informational systems. Data transmission, CPU cycles, and signal processing are all direct, emergent properties of frequency. To operationalize this for algorithmic trading, the specification utilizes a mathematical engine called the Gulf law. This animated equation illustrates the Gulf law. R equals TF times QC times the sum of Fi. This formula takes quantum-level physics and translates it directly into a deployable engineering protocol for financial infrastructure. First, TF is the FTU base tick, our Planck-anchored foundation. Next, QC acts as the translation layer, converting the FTU into localized domain tempo units. This allows distinct systems to operate at their specific required speeds. Because these disparate subsystems calculate their local time as a precise integer multiple of the exact same TF denominator, rounding errors become mathematically impossible. Current industry standards force systems to constantly guess each other's time states, requiring endless algorithmic corrections to mitigate drift. The domain tempo unit mechanism achieves deterministic interoperability across highly asymmetric financial environments. FTU Spec version 1.7.1 is a live, fully audited software standard ready for production. The canonical release includes normative conformance vectors alongside a reference verifier script, FTU verify.1.7.1 pi, guaranteeing precise local execution. The architecture is secured by a cryptographically sealed release manifest, FTU manifest.json, which locks the protocol using SHA-256 hashes. This seal guarantees that the time protocol cannot be tampered with by external actors, nor can it degrade through network interference. This creates an instantly verifiable architecture, providing the mathematical auditability required by both internal risk managers and stringent financial regulators. Consider a scenario where two proprietary trading algorithms are competing for the exact same microsecond arbitrage opportunity. The competitor relies on floating point timestamps and PTP. This diagram shows how their execution packets arrive at the exchange boundary mathematically misaligned. The FTU-enabled algorithm calculates execution using exact integer multiples of Planck-time. The industry has reached the limits of hardware latency. The next differentiator is the shift to absolute synchronization, and firms that do not adopt this standard will find their execution cycles mathematically incompatible with the future of the market.